Hi, Brian Hammermeister here. Here is my IP address, EN0 10.130.46.62. Here's my default gateway 10.130.46.1. Start a Wireshark capture. Private browser. Here's the web page. Okay, it's pulled. I'm going to go ahead and close that to get the fins. Stop the capture. I'm going to create an IP conversation. Here it is here. I'm 62. The other one is 132, 235, 61, 29. Okay, I've created the conversation. You can see here at the beginning, you can see the three-way handshake. Send, SENAC, and ACK right there. Okay, I'm going to create a filter just to look at the synchronize the sends. I'm going to add that to my IP conversation filter. There you go. So you can see here's all the sends. 1, 2, 3, 4, 5, 6 of them. And you can see here the source and destination port numbers right here, 57772. Got another one, 57773 and 774, all right here. And they're all communicating with port 80. Let's remove the send filter. Here is the first HTTP GET frame. If you look at the IP header, follow my mouse, 20 bytes is the header. The TCP header, follow my mouse, 32 bytes. Let's add a destination port filter. That's the first port number used to download the web page. You can see here the source port is all the server starting with 132, and the destination port is all my PC starting with .10. If you look at the sequence numbers here, the first one here is, I'll read the last 5, 14279. Second one, 14280. Just jump down here, 14797. Jump down here, look down here in the detail, 16191. Jump down a couple more, 18979. So you can see how they're going up. Let's look at this in a graph format. Stevenson's graph, again, 14279, 14280, 14797, 17585, 18979. So it's going up just like the raw data. Let's get rid of the destination port filter and add a source one. I'm just going to swap out these 3 letters to SRC. Now you can see here the source is now my PC starting with 10, and the destination is a server starting with 132. And that's all you see is that direction. If you look at the sequence numbers for the first TCP connection, which is port number 5772, the sequence numbers progress up as well. 49081, 49412, 49413. So you can see how they're going up. If you look at the acknowledgement numbers, start back here. Acknowledgements are also going up. 14280, 14797. You jump up to 17585, 18979, 21767. They're also going up. If you look at the first TCP connection of the first image, image 1, I'm showing it right here. Just to make it easier, I'm going to add a filter. Okay, so if you look at it, here's the first data packet. If you dig into that, the file size is 1061 bytes. And then if you look up here, it's supposed the whole length, after you look at all the packets, is going to be 7401 bytes right there, content length. Then you look at the next one, 1394, next one's 1394, next one's 1394, and another 1394 for a total of 4 of those, plus the last one's 764 bytes. If you add all those up, that equals 7401 bytes. Let's remove that filter. Let's add a filter with the fin flags. Okay, you can see here you've got the connections wrapping up here. The first three going from the PC to the server, and then the last three from the server back to the PC, closing out each of those three connections of those three unique port numbers, 7.4, 7.3, and 7.2. All right, let's remove that filter. I'm going to pick out a frame 33 and 34 here. So if you look at these two frames, let's look at the timestamp value in the frames. The timestamp value here is this big long number, and then also look at the timestamp echo reply number right here. Okay. If you compare that with the ACK, which is the very next frame, frame 34, remember this number here ending in 4417. You can see here the timestamp echo reply also, it's the same number ending in 4417. So that's the relationship between those. That's how they're interlinked, those two packets. The timestamp value is different. Let's look at the time column. Go back to frame 33 here. See the timestamp here is 4.942955. The very next frame, frame 34, is 4.943055, just off by a little bit. And I've added a delta time there. It's 0.0001 microseconds that it's off. But if you dig into that frame, you can see that it states the RTT in the frame right here, 0.0001. So that does match. Secure shell into my DigitalOcean server. Okay, I'm in. Okay, I'm going to show you my IP. ETH0 is 178.128.176.247. Okay, I'm going to start Wireshark. Okay, I actually have a conversation filter already blocked in here just to make it easier, or cut and paste in there. I'm going to go on my terminal. I'm going to type the letter L. See, 3 packets are generated. You can see here the first packet, the client, that's me typing. The second one is the server. They are both 36 bytes in length. You can see right there, 36. Okay. The acknowledgement right here is link 0. Okay, I'm going to press enter a few more times. 1, 2, 3. And then now I'm going to activate the NetM emulator. Should be able to cut and paste all these together. And the rest of this one. Okay, and the last one. With the delay, I chose 1500 milliseconds. Okay. Okay, now let's end there. I'm going to press the letter L on my secure shell connection. If you look here, let's look in the packet connection. I'm at 1060. Let's hit L right now. Wow, a lot of frames. Restarting Wireshark here just to clean it up so it's easy to focus on. We'll press the letter L after the capture. You can see I got 3 packets when I hit that. So it's I didn't get anything different. Same number of packets. Okay, the packets you see here are from that first L I hit after adding the delay. I'm going to discuss the Nagel algorithm after hitting the L a few more times. So I'm going to hit it 4 times. 1, 2, wrong place. 1, 2, 3, 4. So you can see there the effect of the Nagel algorithm would probably be best if I just put on a quick filter here for just secure shell just to show it. But you can see the first 2 are the first L that I hit, and then when I hit the other 4, you can see right here they were grouped. See how there's 3 together, and then the server response. So you can see that the Nagel algorithm concatenated or grouped the L's together, sent them together, reduced the overall the packets. Question 27, what can be done on the PC side to avoid exchanging a large number of frames? You saw in question 25. You can simply type out what you want to do in like a Word or a text editor and cut and paste it into the terminal, and that would reduce the number of frames.